Good day, I'm Claire Gutierrez, and on behalf of my co-authors, I will be presenting our paper entitled Comparative Study and Analysis of Particulate Matter Concentrations in the Eastern Part of Metro Manila, Philippines. The air we breathe is one of the most essential environmental factors that sustains life, and its quality can influence both the biotic and abiotic systems in the planet. Multiple problems arise when air quality gets compromised and polluted. To name a few, polluted air can cause health problems in humans and animals, the endangerment of agriculture and ecosystems, damage to infrastructure, and the reduction of air visibility. As such, the World Health Organization has described air pollution as an invisible killer. It is caused by 6 main air pollutants, namely ground level ozone, carbon monoxide, nitrous oxides, sulfur dioxide, particulate matter, and lead. These air pollutants are injected into the atmosphere, which compromises the quality of air. This study focuses on particulate matter, which accounts for some of the worst effects of air pollution. Particulate matter are solid, liquid, or amorphous solid particles that are dispersed in the atmosphere. Particulate matter that cause a significant risk to human and environmental health are called inhalable PM or PM10. PM10 have diameters that are less than 10 micrometers. These particles are able to penetrate the respiratory tract and even get absorbed into the bloodstream, eventually translocating into different organ systems. The picture shows the relative sizes of particulate matter, rather PM10, in reference to tiny particles that are visible to the human eye. PM10 is subdivided into the coarse fraction and the fine fraction. The coarse fraction, or PM2.5 to 10, is composed largely of primary particles produced directly into the atmosphere by mechanical processes such as the breakdown of larger solid particles in construction activities. The fine fraction, or PM2.5, can be formed from combustion sources such as industrial emissions and smoke-producing fuels for heating, cooking, and other domestic activities. PM2.5, or the fine fraction, can also be formed in the atmosphere from gas to particle transformation and condensation of gaseous pollutants, such as nitrogen oxides and sulfur dioxides. To see the impact of air pollution and particulate matter in numbers, the World Health Organization reported that air pollution causes roughly 7.1 million deaths, while Kim et al. Reported that 2.1 million deaths are attributed to particulate matter. The methodology of this study was divided into 3 discrete steps. So first is filter preparation, then sample collection, and then particulate matter analysis. For filter preparation, 2 nucleopore polycarbonate filters with pore sizes of 8 micrometers and 0.4 micrometers were used to filter out the coarse and the fine fractions. The filters were weighed in a Mettler MT5 analytical microbalance after being run through americium in order to remove the static. Following that, the filters were equilibrated for at least 24 hours and were weighed again until 2 weights only had 0.1 milligrams variation. Next is the sample collection. These are the sampling dates, and the sampling site was at the Ateneo de Manila University, specifically in the Manila Observatory. Sampling site was chosen due to city development, a jump in human and vehicular population over the past 20 years. And because of these activities, QC, which is where Ateneo de Manila is located, so QC is one of the most urbanized and densely inhabited cities in the eastern portion of Metro Manila. And as a result of this, QC's air quality is far from ideal. And in fact, it ranks 8th as the worst city in the Philippines in terms of air quality index. The picture shows the sampling site and two nearby nearby highways rather, uh, which are indicated by the red arrows. For sampling collection, again, sampler was used and it was installed at the Ateneo de Manila University, specifically in the Manila Observatory. For PM concentration analysis, gravimetric analysis was used in order to determine the concentration of particulate matter in the sample. For our results, here we show the particulate matter guidelines and limits that are imposed by the World Health Organization and the Philippine government through the Philippine Clean Air Act of 1999. Currently, there are no established standards regarding the limitations of the coarse PM2.5 to 10 load. The limit set by the Philippine government is a more appropriate recommendation since it is based on extensive study of the country's pollutant emissions, socioeconomic status, combustion efficiency, and other criteria used in routine air quality monitoring. For both PM10 and PM2.5, readings from all sampling years exceeded the World Health Organization's more stringent international requirements. In reference naman to the Philippine Clean Air Act, almost all of the sampling years except 2009 surpassed the limit for PM10, while the average PM2.5 in the years 2009 and 2020 complied accordingly. Let's now look at the annual averages in figures. As you can see, PM10 increased from 2001 to 2005, but then declined significantly in 2009 and surged again from 2013 to 2020. So according to the 2002 National Air Quality Status Report, the construction of the MRT along Katipunan, which was started in 2001, may have contributed to higher particulate loadings. Also, there was a lot of ongoing construction of mobile phone transmission towers, which could have influenced the particulate load. And other significant contributors are anthropogenic in nature, such as domestic and industrial activities. In 2009, more than half of PM emissions in the country were from area sources such as gasoline refilling stations and domestic household activities. There are multiple gasoline stations and residential zones near Manila Observatory, which may have contributed to particulate matter emissions. Another major particulate matter source is vehicular emissions. There were 3.8 million registered vehicles in 2001, and that spiked to 6 million in 2005 and further grew to 7.5 million in 2013. In contrast to 2001 and 2005, 2009 showed a decrease in all PM emissions. However, a study by UMOL et al. Noted that in the year 2009, the Philippines was riddled with multiple natural hazards and disasters, especially in Luzon. It was characterized by too much precipitation. Another study by Magtaas et al. In 2019 reported that low particulate matter concentrations were observed on days where it rained in the sampling area. Hence, it may be possible that a washing effect induced by too much precipitation decreased the concentration of particulate matter around the area in 2009. And for 2020, increased particle load may have been linked to increased building activity in the region as a result of the government's Build, Build, Build program. In January 2020, the DPWH announced that continuing road reconstruction was taking place on highways in the vicinity of Katipunan Avenue. So let's now discuss the composition of PM10 concentrations during the sampling years. From the graph here, it can be deduced that fine PM2.5 particles dominated in the sampling years 2001, 2005, 2009, and 2013. So in 2020, the opposite applies, wherein the coarse particle load dominates the PM10 emissions. This may imply that combustion sources in the area may have improved compared to 2001 to 2013. So next, a time series plot was constructed to visualize the daily PM10 and daily PM2.5 concentrations obtained from the sampling period. It also shows the daily PM concentrations in relation to the limits set by the World Health Organization and the Philippine government. What's good about this is we can tell how PM concentrations fluctuate between the sampling dates and backtrack events that may have caused increased or decreased particle loads. So on January 2, 2005, it was noted that a PM10 concentration of 206.71 micrograms per cubic meter was recorded. This exceeded both the Philippine Clean Air Act and the World Health Organization standard. During this sampling date, it is also worthy to note that about 75% or 157.1 micrograms per cubic meter of emissions belong to the fine particle mass, which I'm indicating here in this arrow. This increase in the PM2.5 fraction may be expected during and after events that utilize extensive firework displays. And since the sampling date was January 2, which was just a day after the celebration of New Year, this spike may be attributed to the fireworks during the said period, which created a toxic fog of heavy metals, particulate matter, and harmful chemicals in the atmosphere. In a short amount of time, firework displays secrete high concentrations of fine particulate matter that remains in the atmosphere for days and can increase its concentration about 300%. Moreover, fireworks can potentially cause wildfires and infrastructure fires, leading to the destruction of property and even inflict harm to humans. Another probable event that caused such a high concentration of fine particulate matter during this sampling date was a fire in Bocaue, Bulacan on December 31, 2004 that killed 8 people, injured 3 people, and destroyed about 100 fireworks stalls and residential properties. On January 29, 2020, the highest concentration of PM10 recorded was 128.7 micrograms per cubic meter, which may be due to the Taal volcano eruption that generated a plume of ashfall that spread as far as Quezon City and Caloocan City. A similar event that happened in 2011 was the eruption of Piuhu in Chile, which released ashes and dust that led to more than twice the monthly particulate matter averages in Montevideo, Uruguay. So in conclusion, except 2009, the average PM10 concentration in all the sampling years exceeded the 1999 Philippine Clean Air Act and the World Health Organization's 1-year limit. Also, in all sampling years, the average PM2.5 concentration exceeded the World Health Organization's annual threshold. And average PM2.5 concentrations between 2009 2020 were deemed acceptable by the Philippine Clean Air Act. Thank you.